Okay, we will start with the applied maths integration from NCERT material. Exercise 3.5. Question number 1. Integral 0 to 3 f of x dx, where f of x is equal to x plus 1 for x less than 1 and 2x for x greater than or equal to 1. This is how the question. So you need to integrate from 0 to 3. But if you look at the actual function, you will see before 1 there is a function and after 1 there is a function. In the root of 0 to 3, you have to travel from 0 to 3. In that there is a point called 1. Before 1 there is a function, after 1 there is another function. So I need to integrate them separately. So I will write this as integral 0 to 3 f of x dx. I am going to write it as integral 0 to 1, because till 1 it is x plus 1 is the function dx, plus then integral 1 to above 1 it is 2x, 1 to 3 we need to integrate only till 3, so 1 to 3 it is 2x dx. Now usual integration, x integration is x square by 2 plus 1 is x, that is 0 to 1, plus 2x square is 2 is constant, leave it, x is x square by 2, 1 to 2, 1 to 3. So this 2 and 2 cancel. Here when you apply the upper limit, you will get 1 square by 2 plus 1 minus, now when you apply the lower limit, you will get 0 square by 2 plus 0, plus this will be here only x square, so 3 square minus 1 square. So this answer will be 1 by 2 plus 1, 1 square is 1 only, 1 by, this will be 3 by 2 plus this is 0, that you can ignore, and finally here 3 square minus 1 it will be 8. So the final answer will be 3 into 8 into 2 16, 19 by 2. That's question number 1. What about question number 2? Integral 0 to 1 x root of x 1 minus x dx. If you look at this question, by using one of the properties which we have already discussed, we will be able to work out this easily. So what you can do is, you can use this property, integral 0 to a f of x dx can be written as integral 0 to a f of a minus x dx. This is a property. Using that property, I will be able to write integral 0 to 1, 1 minus x. Wherever I see x, I will write there as 1 minus x. Here a is 1. So 1 minus, again here 1x, there I will write 1 minus x. But since it is a binomial, keep bracket into dx. Integral 0 to 1, 1 minus x. If you open the bracket inside square root, 1 minus 1 will be 0, minus minus it will be plus x dx. Now we can multiply, like distribute root x into 1 is root x, minus x into root x is x power 3 by 2 dx. Now you can directly integrate. Root x will become x power 3 by 2 by 3 by 2 minus x power 3 by 2 plus 1 is 5 by 2 by 5 by 2. This limit is 0 to 1. So we can apply the limit 1, then you will get 1 power 3 by 2 by 3 by 2 minus 1 power 5 by 2 by 5 by 2 minus the rest will become 0 and 0. So no need to look into that, that is becoming 0. 1 to any power is 1 only, then 1 by 3 by 2 is nothing but 2 by 3 minus 1 power 5 by 2 is 1, 1 by 5 by 2 will become 2 by 5. So if you work out this one, you can say 10 minus 6, that is 4 by 15. That is second question. Okay, now let us look at the next question. Question number 3. integral 0 to 4 modulus x minus 2 dx. You need to integrate from 0 to 4. But your modulus function, that is x minus 2, the critical point of x minus 2, that means where x minus 2 becomes 0 is at the point 2. How do I get that? When you equate x minus 2 equal to 0, you will get x equal to 2. That is how I got the number 2. What is special with the 2? Any value after 2, x minus 2 is a positive number. For example, 3 if you choose, 3 minus 2 is positive. The function will be positive. Whereas if you choose a number before 2, that is for example 1, 1 minus 2 is negative. So we have to integrate by removing the modulus sign. To remove the modulus sign, I should make sure that the answer will be positive. So I am going to make sure it like that. Integral 0 to 2, we will split the function. Integral a to b f of x dx can be written as integral a to c f of x dx plus integral c to b f of x dx if c lies between a and b. Using that, I can write integral 0 to 2. You know, in 0 to 2 this is negative. So negative of x minus 2 I consider. Negative of x minus 2, or you can write it as 2 minus x dx. How did I get 2 minus x? Negative of x minus 2. Then plus integral 2 to 4, that is positive place only, so you can leave it as x minus 2 dx. Now just integrate that. That will be 2x minus x square by 2, 0 to 2, plus x square by 2 minus 2x, that is 2 to 4. Now when you apply 2, it will become 4 minus 4 by 2 minus the 0. If you apply, you know that it's going to be 0, plus then when you apply this 4 square by 2 minus 2 into 4, this minus, when you apply 2, you will get 2 square by 2 minus 2 into 2. So this will become 4 by 2, this is 2, 4 minus 2, it will be 2, plus this will be 4 square by 2 means 16 by 2, 8, 8 minus 8, that will be 0, minus this will be 2, 2 minus 4 by 2, 2, 2 minus 4, that will be minus 2. So finally the answer will become 4. Question number 4 is integral 1 to 5 root x divided by root x plus root of 6 minus x dx. Here also we will apply this property. Integral a to b f of x dx can be written as integral a to b f of a plus b minus x dx. Why do I think that I should apply this property? Because here a plus b, 1 plus 5 is 6. So you can get rid of the 6 minus x as x. So we will write this function as the equation number 1. Let me name it as I equal to. Now I equal to, when I apply the property, integral 1 to 5, 1 plus 5 is 6. So I can write root 6 minus x. Wherever there is x, I'll write 6 minus x. Here also I'll write root 6 minus x plus root of 6 minus x, that is in bracket, dx. So this is integral 1 to 5 root of 6 minus x by root of 6 minus x plus this will become 6 minus 6, 0, minus minus x, it will be plus x. This is my equation number 2. You look at equation number 1 and 2. Both integrals are 1 to 5. This is also from 1 to pi you have to integrate, and the denominators of both 1 and 2 are same. So you can add them. So when I add, I will get I plus I. Left sides when I add, I will get I plus I equal to integral 1 to 5. The common denominator is root of 6 minus x plus root x. Now I need to add the numerator. Numerator is root x plus root of 6 minus x. This numerator and this numerator. So if you look at this, the numerator and denominator will get cancelled. So this will become integral 1 to 5 simply 1 dx. That means 2i is equal to, if you integrate 1, it will become x, 1 to 5. So which will become 5 minus 1 when you apply the limit, which is equal to 4. 2i is 4 means I will be 4 divided by 2, which is equal to 2. That is how we reach question number 5. Okay. We will do next question in next video.